One of the best ways to figure out how to add a new capability to an existing application is to get the application running without that capability first, and then think about what you need to change. To help you understand undo as an additional feature, I've created a pair of programs, one that demonstrates a simple capability without the undo, and then a version with undo added. So let me run the program that does a sort of lightweight simulation of a bingo card. This is called undo dots without undo. Here's my bingo card. If I click on one of these black squares, it turns into an orange dot. That's all this program does, and I have no way to undo any of what it does. All right, I'll close this out, and now let's have a quick look and walk through it. I've added a lot of comments. Remember, Visual Studio Code color codes your comments in green, and of course I typically start them with // so if you want to find the comments, just look for the green or the //. It starts like they all do with the project.cs file and the standard boilerplate code. The only thing we do here that's at all different from any other is I create an undo dots object. It has an Avalonia window called win, and I use that in the app run call. Not much to see here. Let's look at undo dots. Here are all the comments that will help you understand it. I'm not going to read them all to you here, but they're there for you to read so that you can work your way through this program one step at a time and find out how it works. I've actually separated out some of the initial steps that happen in the undo dots constructor into methods all their own. Not because that's actually a particularly good programming practice, but you can look at the methods one by one and see what they do kind of in isolation. So we start by making the main window. If I were to scroll down here to the make window method, you'd see there's not much to it. It's really just the same code we'd use if we were creating the window in line the way we typically do. But I broke this out to show you that you can isolate these things to keep it easier to understand. So I make the window, then I make a grid. Then I get some bitmaps, and those are used to create the images. In this case, I only need two, the black square and the orange dot. Then what I'm going to do is create the individual entries that go into the 5x5 matrix in the grid. That's worth looking at. Load images into, and I pass a variable that contains a reference to the grid I created back here at line 30 as an argument to load images into. So let's look at load images into. It has two loops, one inside the other. This is a pretty common construct when you're working in two dimensions, something made up of rows and columns. You'll do whatever it is you're going to do once for every row, and for each row, you'll do whatever it is you're going to do once for each column. Since I have 5 rows and 5 columns, if I do my inner loop for the columns 5 times, and I do that 5-time loop for each of 5 rows, I'm going to do whatever's inside that innermost loop 25 times, once for each cell. What I'm doing in this case is I'm creating an image. I'm loading as my source picture the black square. Then I'm going to create some other object called a cell handler. We'll look at that in a moment too, but the important thing is I tell the cell handler what row and column, tell it what cell it handles, the image I want it to show at that cell, and a copy of the orange dot picture so they can add that later if the cell gets clicked. I also add a method called onPointerPressed, which is defined in the cell handler, to the image's pointer-pressed event. You've seen this before in the goat problem. So now anytime I click on one of the images in the grid, that grid cell's cell handler's onPointerPressed method will run. So I've got one cell handler for each cell in the grid, and that particular cell handler has its onPointerPressed method run when I click on the image in that cell. I do a couple of set values to position the image, and then I add it to the grid. Now let's look at cell handler. When I call the cell handler constructor, I pass it the row, and I pass it the column of the cell it's constructing. I also pass in a reference to the image to show and a reference to the orange dot picture so that it can change that initial black square to an orange dot later if it gets clicked. The constructor only copies those 4 things to local variables. private member fields that are part of the class. So row gets copied to my row, column gets copied to my column, and so forth. I have to save in particular the image and the orange dot. Remember, I also assigned to the image's pointer pressed event this method, onPointerPressed. So once my grid is visible, anytime I click on an image, the particular cell handler object's pointer onPointerPressed method, the particular cell handler object that handles that cell, will have its onPointerPressed method run. Well, all I have to do is change the image in that cell so that its source becomes the orange dot, and then I return. In fact, here I'm not actually changing it. I'm checking to see has it already been changed. If it has already been changed, there's really nothing to do. If it hasn't been changed, I change it here. That's how this works. There's only 3 files that are in the actual executable. The project.cs, which we have for everything, the undo dots that creates the window, the grid, and all the cell handlers, and the cell handler. And remember, we have 1 cell handler per cell, so that every time you click on an image, the particular cell handler object that manages that cell has its onPointerPressed method run. Next, what we're going to do is see how we add some code to this that will allow us to undo the changes and get the black squares back.